February 14, 1943. Kasserine Pass, Tunisia. Late afternoon. Cold wind cuts through the mountain gap, carrying the smell of dust, fuel, and burned metal. The ground is scarred with fresh tracks, tank treads, supply trucks, half-tracks pulled off the road in haste. Somewhere beyond the ridge, artillery thumps in dull, rhythmic bursts. A German officer stands beside a Panzer IV, binoculars pressed to his eyes. He is calm, confident. He has read the reports. American units are ahead, inexperienced, poorly led, driving machines that look like tanks but are not built like German ones. He lowers the binoculars and says nothing. There is no urgency in his posture, no sense of danger. This, he believes, will be another demonstration of German superiority, discipline, engineering, and doctrine crushing an opponent who has arrived too late and learned too little. The assumptions are already in place, and they will shape everything that follows. If you care about real World War II stories, not myths, not Hollywood versions, but the moments that actually changed history, then this channel is made for you. Subscribe to keep these stories alive. Like the video so it reaches others who still value history over noise. And if you know a friend, a veteran's family member, or anyone who grew up hearing these stories, share this with them, because these stories weren't meant to disappear quietly. They were meant to be remembered. For the German command, the American army is still an abstraction in early 1943. They know the numbers. They have studied photographs. They have examined wreckage from early encounters in North Africa. What they see confirms what they already believe. American tanks are tall, thinly armored, awkwardly shaped. American aircraft are rugged but inelegant. American trucks are everywhere, but look civilian, almost improvised. To German eyes, trained in a tradition that prizes precision, compactness, and mechanical sophistication, this does not look like a serious military force. It looks like an industrial improvisation. German officers are not ignorant men. Many are technically educated. Some trained as engineers before the war. They understand metallurgy, tolerances, ballistics. They measure quality by thickness of armor plate, length of gun barrels, refinement of optics. They believe that war is decided by superiority at the point of contact. Better gun, better armor, better machine. That belief has served them well so far. What they do not see is philosophy. They examine American weapons through a German lens and conclude that the Americans simply do not understand war the way Europeans do. They interpret simplicity as incompetence, standardization as lack of innovation, ease of repair as a concession to mediocrity. An American tank breaks down more often, proof of poor design. An American engine is oversized, wasteful. A vehicle designed to be repaired quickly, an admission of weakness. Every observation reinforces the same conclusion. The Americans build equipment for amateurs. In reports moving up the German chain of command, the language is dismissive. American armored units lack tactical finesse. American vehicles rely on mass rather than quality. American crews are poorly trained and overly dependent on material superiority. These are not propaganda statements. They are internal assessments. They shape planning, deployment, and expectations. An expectation in war becomes behavior. At Kasserine Pass, those expectations harden into certainty. When German armor advances, they do so with confidence born not only of experience but of belief. They expect American vehicles to fail under pressure. They expect American units to collapse once leadership is disrupted. They expect that a sharp blow will expose the weakness beneath the steel. And initially, they are right. American formations buckle. Orders are confused. Equipment is abandoned. Tanks burn. From the German perspective, this confirms everything. The American army is large. It is loud. It is clumsy. And it is not ready. But beneath the visible chaos, something else is happening. Something the German command does not register. American units withdraw, yes, but they do not dissolve. Vehicles are repaired and returned to service at a pace the Germans find strange. Losses are replaced quickly. Units that should be crippled reappear days later, reorganized, re-equipped, reinforced. To German eyes, trained to think in terms of elite formations and limited reserves, this is puzzling but not alarming. Yet, the German command continues to evaluate American engineering through static criteria. Armor thickness, gun penetration, vehicle silhouette. They compare tanks in isolation, aircraft one-on-one, weapons system against weapons system. What they do not measure is time. How long it takes to repair a March 3, 1943.
Berlin.
German Army Ordnance Office. Midday. The room smells of paper, ink, and cigarette smoke. Sunlight filters through tall windows, catching dust in the air. On a long table lie technical drawings, cross-sections of tanks, armor thickness charts, penetration tables neatly calculated to the millimeter. Several officers stand around the table, their tunics immaculate, boots polished. This is where conclusions are formed. Not on the battlefield, but here where war is reduced to diagrams and specifications. An American tank profile is pinned to a board. Someone taps the drawing with a pencil. Too tall, too thin, poor silhouette. Heads nod. The verdict feels obvious. German military thinking in 1943 is still deeply shaped by pre-war assumptions. War, as they understand it, is decided by decisive encounters. When superior machines meet inferior ones, the outcome should be predictable. This belief is embedded in doctrine, reinforced by early victories, and validated by years of success against opponents who could not match German tactical concentration. Engineering in this worldview is about optimization. Make the best tank. Make the most lethal gun. Make the most refined aircraft. If each component is superior, the system will be superior. American engineering does not fit this model. German analysts notice that American vehicles are designed with excessive margins. Engines larger than necessary, transmissions that seem crude, armor layouts that prioritize internal space over external profile. To German eyes, this looks like inefficiency. What they do not recognize is intention. American engineers are not trying to win a duel. They are trying to keep a force moving under conditions where perfection cannot be maintained. They design vehicles assuming they will break. They assume crews will be inexperienced. They assume parts will be damaged, replaced, swapped, and reused in the field. Reliability, in the American sense, does not mean never failing. It means failing in ways that can be fixed quickly. This distinction is subtle but decisive. German tanks are marvels of precision, but precision has a cost. Tight tolerances require skilled labor. Complex systems require careful maintenance. Repairs often require specialized tools and trained technicians. On paper, this produces excellence. In prolonged war, it produces fragility. German officers do not ignore logistics, but they see it as secondary to combat performance. Supply exists to support the fighting force, not to define it. Vehicles are designed first for battlefield superiority, with sustainment treated as a necessary inconvenience. American doctrine reverses this hierarchy. The vehicle exists to be sustained. The system exists to keep moving. Combat power is expected to fluctuate, but the flow must never stop. This is not articulated explicitly to the Germans. They are simply watching the wrong things. Reports from North Africa mention something unsettling. American units recover equipment faster than expected. Destroyed vehicles are replaced with unfamiliar speed. Supply convoys appear relentlessly, even after heavy losses. German commanders attribute this to wastefulness, to brute industrial scale, to a willingness to accept inefficiency because resources are abundant. They miss the deeper truth. Standardization. American vehicles share parts. Engines, transmissions, radios, weapons, all designed to be interchangeable across platforms wherever possible. A damaged tank is not a unique problem. It is a modular one. This philosophy does not impress German engineers. It alarms no one. In German planning circles, American industry is acknowledged, but underestimated in how it is integrated into military thinking. Factories are seen as distant civilian entities. Production is something that happens behind the scenes, not a battlefield variable. This separation does not exist in American doctrine. In the American system, factories, ports, railways, training depots, and frontline units are all part of the same machine. German command does not yet understand that it is fighting not just soldiers but a process. On the battlefield, the consequences begin to surface quietly. German units score tactical victories, but find themselves facing fresh American formations sooner than expected. Equipment losses that should cripple a unit only slow it briefly. There is frustration but not alarm. Not yet, because the German command still believes the decisive moment is coming. A moment where superior engineering will assert itself decisively. They are still thinking in terms of single battles. The Americans are thinking in terms of continuity. Back in Berlin, the pencil is set down. The file is closed. The conclusion remains unchanged. American engineering lacked. July 10, 1943. Near Gela, Sicily. Early morning. The heat arrives before the sun clears the horizon. Engines cough, then settle into a steady roar. Dust hangs in the air, coating uniforms, goggles, and exposed skin. An American armored column moves inland from the beaches. Vehicles spaced evenly, radios crackling with short, efficient transmissions. A German anti-tank crew watches from concealment. They wait. When the lead Sherman crests a shallow rise, the gun fires. The impact is clean. The tank burns. Smoke rises quickly, thick and black. From the German position, it looks familiar, satisfying. Proof, once again, that American armor cannot withstand a properly placed shot. But the column does not stop. The second tank maneuvers around the wreck. The third pushes forward. Infantry dismounts, spreading out with practiced urgency. Within minutes, American artillery begins to fall. Not precise but overwhelming. The German crew realizes too late that they have revealed themselves. Pressure arrives before they can relocate. This is the moment German commanders struggle to interpret. Individually, American machines still appear inferior. Shermans burn. Aircraft are shot down. Vehicles break under strain. None of this contradicts German assumptions. What contradicts them is tempo. American forces do not pause to restore perfection. They accept damage and continue. Loss does not halt movement. Failure does not disrupt the plan. The war suddenly feels continuous. German doctrine is built around controlled escalation. Identify weakness, exploit it decisively, then consolidate. That model depends on pauses, moments to regroup, to repair, to reorganize. The Americans deny those pauses. On Sicily, German units discover that destroying American equipment does not produce the expected operational effects. Tanks lost in the morning are replaced by evening. Units pushed back one day reappear the next, with fresh vehicles and unfamiliar faces. There is no time for German commanders to recalibrate. The pressure never releases. This is where American engineering begins to reveal its true purpose. Shermans are not designed to survive every hit. They are designed so that crews can escape, learn, and fight again. Hatches are accessible. Internal layouts prioritize human survival over compactness. German tanks are harder to kill, but when they are hit, the consequences are often final. German crews know this. They fight with the understanding that a single mechanical failure, a single penetration, may end everything. American crews fight knowing replacement exists. This difference changes behavior. As the campaign moves into Italy, the pattern intensifies. German units execute skillful defenses, inflicting disproportionate losses. But those losses do not accumulate in the way German planners expect. American formations absorb punishment and continue advancing. There is no dramatic collapse. No singular breakthrough. Just steady, grinding movement forward. German engineers begin to notice something unsettling. American vehicles appear on roads where no vehicles should be able to operate. Mud, dust, heat, conditions that strain German equipment, do not stop American movement. Not because American machines are invincible, but because they are maintained differently. Field repair becomes routine. Crews replace components without waiting for specialists. Damaged vehicles are cannibalized efficiently. Nothing is wasted. Nothing is sacred. German engineering culture treats machines as precision instruments. American engineering treats them as consumable assets. This philosophy bleeds into command decisions. American officers do not hesitate to commit forces they know will suffer losses, because the system behind them is built to replace those losses quickly. German officers hesitate more with each passing month, not from fear, but from scarcity. Each loss matters more. Each breakdown hurts more. Each delay compounds. By late 1943, German after-action reports begin to shift in tone. They still criticize American equipment, but now note something else. December 16, 1944. Ardennes Forest, Belgium. Dawn. Snow muffles sound. Trees stand motionless, their branches heavy with ice. German engines idle under camouflage nets, exhaust drifting low and thin in the freezing air. Inside armored vehicles, crews sit in silence, gloved hands resting on steel, breath fogging the interior. This is meant to be the moment when German engineering and operational surprise reassert control. One decisive blow, one concentrated effort, one final demonstration that quality still outweighs quantity. The offensive begins. First, it works. American positions are overrun. Units are cut off. Roads clog with retreating vehicles. German armor advances through gaps created by speed and surprise. For German commanders, this feels familiar. This is how victory is supposed to look. But something is different this time. The Americans do not collapse the way earlier enemies did. They bend. They retreat. They reorganize. And then they return. In the frozen villages and forest roads of the Ardennes, German crews begin to notice patterns that do not fit their expectations. American vehicles appear quickly after losses. Damaged tanks are abandoned without hesitation, crews already moving to replacements. Supply convoys continue despite weather that should make movement impossible. The battlefield is not emptying behind the retreat. It is filling. German tanks, technically superior on paper, struggle in ways that are not immediately visible in combat reports. Fuel shortages immobilize vehicles that are otherwise intact. Minor mechanical failures become catastrophic due to lack of spare parts. Complex systems fail in cold conditions they were never designed to endure. American vehicles, less refined but simpler, continue to function, or are replaced when they do not. German commanders had believed American equipment was wasteful. Now they see that waste was calculated. At the tactical level, German officers still win engagements. At the operational level, they begin to lose control of time. Every delay benefits the Americans. Every pause allows fresh units to arrive. Every destroyed American vehicle is removed, replaced, and forgotten. German losses accumulate. American losses are absorbed. This asymmetry is not yet fully understood, but it is felt. By January 1945, German commanders recognize that the offensive has stalled. They look for explanations in familiar places. Insufficient fuel, uncooperative weather, enemy numerical superiority. They still do not confront the deeper issue. They are fighting an opponent whose system is designed to endure disruption. American engineering shows its true value not in moments of triumph, but in moments of strain. Repair depots operate continuously. Replacement crews arrive already trained on standardized equipment. Damaged vehicles are stripped, repaired, or discarded without ceremony. There is no expectation of perfection, only continuity. German crews experience the psychological weight of this imbalance. They fight knowing that every loss is increasingly irreplaceable. They conserve equipment, hesitate to risk breakdowns, avoid movements that might damage their machines. American crews fight knowing that the system behind them will catch them if they fall. This knowledge shapes behavior. It shapes risk. It shapes morale. It shapes endurance. German command begins to sense that engineering alone cannot reverse this dynamic. New tanks arrive too late. More complex designs require more resources, more time, more skilled labor, none of which Germany has left. The war is no longer a contest of brilliance. It is a contest of survival. And American engineering was built for exactly that. As the Ardennes offensive collapses, German officers file reports that are markedly different from those of earlier years. The tone is no longer dismissive. It is cautious, concerned, measured. American equipment is still criticized. But now it is accompanied by an acknowledgement that criticism does not stop it. The assumptions that guided German planning for years are no longer reliable. They have failed under sustained pressure. And there is no time left to replace them. The realization comes quietly, not as a revelation but as an exhaustion. German command did not lose because its machines were inferior. It lost because it misunderstood what kind of war it was. April 11th, 1945. Near Magdeburg, Germany. Mid-morning. The road is crowded with the remnants of an army. Abandoned vehicles line the ditches. Some burned, others intact but out of fuel. Broken equipment lies where it was left, not destroyed by enemy fire, but by time, scarcity, and retreat. An American column moves past slowly. Sherman tanks, fuel trucks,
Rapai vehicles,
ambulances, bridging equipment. The formation is not elegant. It is not quiet. It is not subtle. But it does not stop. German officers watch from ruined buildings and forest edges, no longer attempting to engage. There is nothing left to gain. What they see now is not defeat in a single battle, but the final consequence of a long misjudgment. The Americans did not outfight them tactically at every turn. They did not outdesign them in terms of mechanical brilliance. They did not seek perfection. They applied pressure. Relentless, organized, sustained pressure. In the final months of the war, German commanders finally articulate what had gone wrong, but only in fragments. American logistics functioned as a weapon. American standardization erased the impact of losses. American engineering prioritized the survival of crews, not machines. These observations appear in reports too late to matter. The system that produced German excellence could not adapt quickly enough to a war that demanded endurance above all else. German engineering culture prized mastery. The American system prized function under failure. That distinction defined the outcome. After the fighting stops, the contrast becomes even clearer. American units continue moving, repairing roads, rebuilding bridges, transporting displaced civilians. The same systems that sustained combat now sustain peace. German infrastructure, by contrast, collapses under the weight of its own specialization. Complex machines without spare parts. Precision tools without factories to support them. What once looked superior proves brittle. This is not a story of inferior German thinking or superior American intellect. It is a story of assumptions. German command assumed the war would be decided by decisive engagements between finely crafted machines. They assumed that quality would naturally overwhelm quantity. They assumed that their criteria for excellence were universal. They never fully considered that their enemy was solving a different problem. American engineering was not built to win duels. It was built to ensure that the duel never ended. If a tank was destroyed, another replaced it. If a crew was lost, another took its place. If a road was blocked, another was built. The war continued not because American machines were better, but because American thinking allowed no pause. For German soldiers and engineers alike, the realization came too late. Not in a moment of revelation, but in the slow recognition that effort no longer produced results. That skill no longer translated into advantage. That brilliance could not overcome a system designed to absorb and outlast it. This is the cost of underestimation. Not humiliation, not shock, but inevitability. World